Good morning, everybody. Thanks for joining my talk. We'll be talking about asynchronous request processing. So my name is Jan. I'm a senior web developer and architect at Lididoo. We're a German Frankfurt-based e-commerce startup, and I mainly deal with Symfony, Silex, Sileus, and Graph. So as we all heard from Fabienne this morning, apparently Silex will be deleted from this list rather soon. But OK. Why do we talk about requests? I have this really nice quote here from Fabienne. It's a bit old, but I guess it's still relevant. Symfony is a request-based framework, so nearly everything we do in Symfony is triggered by a request. But for the sake of this presentation, we can also think of a request as something that comes in via a command line argument, a command line execution, a cron job, or whatever you have. So the request is really just the trigger for us. Oh, and by the way, if you have any questions, don't hesitate. Just raise your hand, and we'll see that we can address them in a timely manner. So the conventional way of handling a request is this one. We have the request coming in. It's going to be routed to one of our controller services by your front controller. And then we trigger some logic, and we turn the response to our visitors. In the new and asynchronous way, though, we have the request coming in. It's going to be routed to our controller, and the controller will then trigger some other logic somewhere in the system that runs in parallel in an asynchronous manner, and we can return the response to our customer faster, thus saving time in response and making a better user experience in the process. So what other benefits do we have? We can move long-running logic from our web service. We can cut down reaction times, as I've already demonstrated. We can exchange data and messages with other systems. And keep in mind here that these other systems don't need to be written in PHP. For example, we use other subsystems in Go, Java, Node, and even Swift. So that's a really easy way to exchange data without having to provide a full-fledged REST API. You can also transfer load to machines that are probably better equipped to handle it. For example, if you have users uploading video, you might move the actual rendering or transcoding process to a machine somewhere on AWS that is equipped with a dedicated graphic card and that can therefore handle the process much better than your actual web server that accepts the incoming video file. This also enables the use of microservices, which we don't have to talk about now. And it also helps you scale and parallelize your application. OK. So this is the general overview of how messaging systems mostly work. You have your application on your far left side, and that publishes or sends, depending on the library you use, the vocabulary might change a bit here and there. It sends a message to your message broker that keeps track of all the messages, and maybe even has a persistent layer in your file system, memory, database, what have you, and then sends these messages out to your consumer or processors that then take care of the actual work. Some of the libraries we'll be looking at actually have a back channel and can report the state of the message that they're working on right now. So the server always knows whether a message is in progress, has been processed successfully, or might have even failed. OK. This talk is going to be a tale about 3 systems that we use for queuing: Gearman, Resque, and RabbitMQ. Has anyone ever heard of one of these? Oh, that's nice. Which one? Who has heard of Gearman? I'm sorry. Who has heard of Resque, PHP Resque in particular? Nice. And who has heard or used of RabbitMQ? Wow. Why are you all here? OK, so Gearman, just really quick, is a rather ancient job server written in C. You can install it as a daemon. You can use the Packle extension for your workers. And there are also extensions and APIs for tons of different languages. I think for every language under the sun, there is a Gearman extension. That's how you would usually use it. It's the example taken straightly from the tutorial. So you just define your job as a JSON text message. In this case, we have a JSON payload, and we send it. That's funny. And we send it to the consumer. Then we have a working thread that is most often started by supervisor D or as a detached process on your web server, and that works through all these messages. The bundle and the Peckle extension are, let's put it nicely, outdated and not that actively maintained anymore, which is why I would advise any of you against actually integrating Gearman in an application. If you already have it, it's OK. You can keep using it. It's fairly stable by now, but I wouldn't introduce it now as a dependency. OK. PHP Resque. So for those of you who don't know Resque, Resque is a messaging and job system that's actually coming from Ruby and has been ported to PHP as PHP Resque. And therefore, it, of course, needs a Redis cluster to run, or just a single Redis instance. That's also fine. And it brings all the ups and downs of Redis with it. So we, of course, have a persistence layer there, but we also have atomic transactions, which is really nice if your business logic depends on those messages. There is a demo application. Apparently, most of you don't need it, but you can check it out in my repository. Also, the slides will be published later on, so you can check out the application then. Let's just have a look at the quick setup. Of course, we need to download the bundle and register it. And please excuse my really verbose slides here, but I think, or I always try to have my slides in a way that when you look at them in a few months' time, you still kind of get the whole gist of the talk. So we can skip over most of that here, but hopefully when you look back at those slides, it will help you. So we define what is called a job in Resque, which needs to implement a public run function, and that function is executed every time the message is processed in the worker. And we can have all kinds of arguments as part of the message. Have a look at this right now. Every time we want to trigger a job, we can send arbitrary data as arguments for a message, and this will be the payload for the new message we just triggered. And then we queue this job. By default, we just have one queue, and we send it to the default queue, which is fine for most systems as long as you don't need to separate or prioritize various kinds of messages. You can just use the default queue. Then we start one Resque worker. It's just one thread that takes care of all the incoming messages. And if you would do this on a live and production server, you'd probably start this as a detached progress, or use something like supervisor D to have it run in the background. So RabbitMQ is a message broker in Erlang. It uses the AMQP protocol, which is an open but binary protocol. So therefore, we can integrate other systems and services that use the same protocol. The key advantages it brings with it are routing and distributions. So when we check the next slide, we see here that the actual routing process is a bit more complicated than on your usual working system. When we publish the message, we first publish it to an exchange, which is sort of the inbox for RabbitMQ. And then based on various routing rules that you can set up, so for example, you can analyze the payload, you can set up static rules, and much, much more. We then send the message to the actual queue. And the queue is then the place where the messages are being collected and sent to the consumer processes. Also, what's missing here, but what is of course part of RabbitMQ, is the back channel. So the RabbitMQ server always knows the state of all of its messages. So the setup again, we'll skip right through it. And we of course need to install the bundle and register it. We need a configuration. So this is a bit more complex here. We need to register what is called in RabbitMQ syntax a producer and a consumer. A producer is the service that will be publishing the messages to the server, and the consumer is the service that will process each messages. And these configurations will automatically be parsed by the bundle, and the bundle will then publish on-the-fly configured services in your Symfony application that you can use to publish and consume those messages. And we can see here on this consumer, the actual callback is an existing Symfony service, and this service is the one that will be executed every time we have an incoming message. OK. So this is the job for the message. We publish this. We start the consuming thread. And now to the good stuff. So my company and I personally, we ran through all these different libraries that you just saw. And there are some lessons that we learned along the way that I would now like to share with you. Most importantly, the ones regarding the worker thread. So PHP is not meant to be long running. Given that many of you already use messaging systems and PHP consumers, how long do you run your services? Anyone running a working thread in PHP longer than an hour? Oh, 1, 2, 3. Longer than 2 hours? Possible, nice. Shorter than 30 minutes, 15 minutes? OK. So in order to keep a check on how long these services should run, these processes should run, and how much memory they can consume in that time, I advise you to use supervisor D to start the threads, shut them down after a certain amount of time, and automatically restart them. Keep in mind, though, that depending on the library you use and on your configuration, booting up a new consumer can take really, really long. So I've seen setups in RabbitMQ where you have something north of 20 or 30 queues and routes, where starting a single consumer might take something between 30 and 60 seconds. So restarting that consumer every 5 minutes is probably not worth it. The time it takes to start the consumer, and thus the time it should run, fairly strictly depends on your application. So that is something you need to figure out over time. And you will learn it sort of automatically on the go as you introduce more and more threads. Something else to keep in mind is open database connections, especially if you use MySQL. It's a common problem in PHP and MySQL applications that if either your PHP thread is really long running or your thread is somehow disrupted, the MySQL database connection remains open, and therefore reduces the amount of available connections or causes timeouts in your database. So that's something you have to keep in mind. And also something you can do, again, depending on the logic of your consumers, is you can have the consumer shut down by itself if you can kind of forecast that there are no messages incoming, thus, again, freeing the connection to the database. What you can also do with libraries like RabbitMQ, you can tell the consumer to shut down after a certain amount of messages. That is something you should keep in mind whenever you have a payload or a service in your consumer that you know causes a memory leak. And sometimes there's nothing you can do about it because it's a dependency or it's a third-party tool that you integrate. So that's always something to keep in mind, to just have the consumer automatically shut down after a certain amount of time. Also, RabbitMQ, as one of the few libraries, uses soft quotas for memory management. So you can tell your consumer process to not use more than a certain set amount of memory. And RabbitMQ then tries to forecast the amount of memory it will need for the next few messages. And if it's going to hit that limit, it will restart the consumer automatically. Then prefetching. Prefetching is also a feature of RabbitMQ and enables the consumer to not only get message by message, but to fetch them in the bulk and then process them one by one, thus reducing the network overhead between each processed message. Keep in mind, though, that depending on your application setup, that might shuffle around the order of your messages. So if you depend on the messages being processed in exactly the right order as they were being published, you might have to be careful there. And of course, for your consumer and producer classes, you don't have to use the default RabbitMQ implementations. You can use custom classes, which is really helpful with common tasks like logging and debugging. So far, any questions? Yeah, one.
I have one. So you say that it's optimal to shut down the consumer after a certain amount of time. I was wondering if it's feasible to have some sort of cleanup function where you maybe free the memory and resources.
Yeah. So the question was whether instead of having to shut down the consumer every time, just have a logic in your consumer to free up memory if you know that there is a leak, right? Yeah. OK. Of course, you can do that. But the case I was talking about is sometimes there are leaks that you just can't do anything about it. A really good example is the Doctrine unit of work, that when it's really long running, just amasses references to all the objects that passed through. And while you can clear it and flush it, that doesn't really help in all the cases. But yes, there are hooks in the RabbitMQ messaging lifecycle that you can hook into and say, for example, after every processed message, call these methods, and do this and that to actually sort of like steer away from memory leaks. But that's not always all there is. Sometimes we just can't help it. Yes?
You mentioned ordering.
Yeah.
Presumably it's best practice for asynchronous processing to not to be reliant on an order, that you can do everything distributed.
Yes, this is something, order is really important. So in an ideal world, your messages shouldn't be interdependent on one another. So for example, that you can introduce a second or third or fourth consumer and have them split the load, not worrying about the order that the messages will be processed in. But sometimes, especially in legacy applications, people just build their messages in a way so that they depend on the message before that, and the next message again depends on the one you're processing right now. For example, I've seen systems that use message brokers to import bulk CSV files. And the legacy CSV importer was built in a way that each line can only be parsed if the line above it has been parsed correctly. So yeah, you can split out that process in several messages for each line, but you still depend on the line before you. So in that case, you actually only introduce network overhead and you don't gain any of the benefits. But yes, if you set up a messaging system from scratch or introduce it to your application, please try to do it in a way that message ordering is not important. That's also especially important because any one single message can fail. You can lose your database connection. You can run into a network timeout. You can run in a memory problem on your host machine. All this stuff can happen, and it will happen, trust me. And when the message fails, a good messaging system will requeue that message so that the data is not lost, and you will have another chance to handle that message in the future. But that does definitely change reordering because the message is not placed back in front of the queue, because that would cause like an infinite loop, but it's going to be sent way back to the queue. So that's one of the points that will actually reshuffle your messages. Nothing else? OK, then we can go on. Talking about messages, try to keep your messages short, especially when using RabbitMQ, because all of your messages will be kept in memory as long as possible, for performance reasons, obviously. The first time I used RabbitMQ, I just serialized all the PHP objects as message payload, and that's a massive overhead. So the way better solution would be to either use JSON or XML as message payload data and then use a serializer to rebuild the objects in your consuming thread. Also, when you use JSON or XML and don't actually use serialized PHP objects, other subsystems can work with that message as well, whereas serialized PHP objects only work in PHP. Transformation. Again, sorry for the last point. I'll read that out. So as I said, use the serializer. And also, if you serialize entities that actually came from the database and you send them to your messaging systems, either just transfer the ID as a payload, or when you serialize the whole entity, make sure that you reload the entity in your consuming thread, because the state of that entity and the state in the database might have changed by the time that your consumer actually processes that messages, depending on what you do, of course. OK. Regarding the message format, most of these libraries support message headers. So you don't only have a payload, but you can also have a header for various kinds of metadata. One thing I'll strongly advise you to do is use that header to version your message format, just like you would do in an API that is public, because you need to have a certain kind of contract between all the relevant processes so that they know how to serialize and deserialize your messaging format. And you can also set a content type if your messaging system is so complex that you support messages of various content types, for example, XML and JSON at the same time. And something we came across and that helped us a lot is to introduce unique IDs for each message. So don't have only the IDs of the entities you're working with, but also create a unique ID for the message before you publish it, so that the debug trace is consistent with that ID throughout all of your systems. And then again, other metadata, of course, can be added: timestamp, session data, user IDs, application IDs, tokens, whatever you need. OK, deployment. This is the fun part. So of course, when you use your Symfony application as your consumer thread, it has a code base that is hopefully often updated. And then you need to update the code on your running systems. For that, you need your workers to be able to shut down gracefully. It might not always be feasible to wait for your consumers until they have processed all the messages there are. Sometimes you have a backlog of thousands or hundreds or millions even of messages, and you can't wait with your deployment. So your consumers need to be able to shut down mid-message. RabbitMQ really nicely supports this out of the box because it keeps track of the message state. So you can shut down the consumer while it's processing the message, and the message will automatically be requeued because the consumer hasn't acknowledged and finally processed that message yet. What you need to keep in mind, though, is that in your consumer thread, all persistent operations, database flushes, write out to disks, and so on, should occur at the very end of the process so that when you restart that message or you reprocess it, your database flush or your write outs won't be doubled or tripled throughout the system depending on how often you need to run that message. Or the more complicated part is to simply make sure that consumers can only be shut down when they're idling. That is something rather difficult to do because you have to keep track of what your consumers are doing and you have to integrate that in your deployment process. We don't really have that much time to talk about that now, but you can catch me outside. I'll still be around for a few more hours and we can talk about how you can do that. Otherwise, you might run into loss of messages, and always keep in mind that a lost message might mean lost data because it might not be persisted anywhere else in your application besides your queue. Other challenges. So of course, introducing messaging system in your application is a change of infrastructure and should therefore be kind of thought about before doing, especially when you have no experience with that topic beforehand. I'll strongly advise you to use something like PHP Resque instead of starting straight with RabbitMQ because it's way more overhead and way more complicated to set up. Also keep in mind that just because you moved load somewhere doesn't mean you removed it from your system. Somewhere, some poor server still has to handle it. And don't make the mistakes that others did. For example, I once saw a client of ours setting up a whole messaging system and then running the consuming threads on the same machine that the web server was running on. And that's no help, really, because when you start to really hammer on those queues and write a huge backlog, you'll just slow down your application web server. And then, yeah, shit hits the fan. Sorry. Again, rethinking is necessary. For example, status displays, push messages to your customer. Once the message is in the queue, your PHP thread there's no success callback as we would have in JavaScript or a Node. So your front end either has to keep polling for new information, or you might have to introduce something like a WebSocket to push notifications to your front end, because as we saw in the very beginning, your response has already been sent. Then, as we already talked about, interdependencies of messages. Please don't do it. Don't. And keep in mind that Doctrine, no matter whether you use ORM or ODM, really isn't made for long-running processes and batch processes. OK, I guess we're finished just on time. Please rate this talk. If you think it was good, rate it on Joined In. There's the link. If you think it was bad, text me on Twitter. I'll try to make it better the next time. This is actually the first time I've given this talk on a major conference, so I really appreciate any feedback. And if you have any more questions, reach out to me or find me in the hall somewhere over the day. And thank you.